Good morning students, welcome to my channel Chemical Crystal Palace. Today's video is on valency and how to write chemical formula part 2. So in today's video I'll be providing you all with a valency chart. Then we will discuss about the rules for writing the chemical formula and I'll be teaching you how to write a chemical formula. So let's start with the valency chart. We have the positive ions, in which the ones with the valency 1 are called the monovalent elements. Under this category comes is sodium with the charge +1. All the elements here have the charge +1. Lithium with +1. Potassium, hydrogen, all are with +1. Copper 1 also is called the cuprous. It shows these elements show variable valency, which we discussed in the last video. So this is copper 1 or called cuprous ion, that is copper plus. Mercurous 1 is called Ag1+ or hydrogyrum, this is the Latin name. Gold 1, Aurus Au+1, that is Aurus is the aurum is the Latin name. And silver also called argentus with +1. A monovalent radical is ammonia with NH4+ formula. The ones with valency 2 are called the divalent elements. In this we have calcium 2+, magnesium 2+, beryllium 2+, strontium 2+, barium 2+, zinc 2+, manganese Mn2+, or also called manganese ion. Then we have silver 2 or the argentic 2+ ion. Next we have cobalt 2+, uranium also 2+, U2+, copper 2 or called the cupric ion is Cu2+. Then we have iron 2 or the ferrous Fe2+ ion, mercury 2 or the mercurous Hg2+ ion. Then lead or plumbus we have Pb2+, tin 2 or stannous, or this is the Latin name, plumbus is also the Latin name, Sn2+ is tin, and platinus or platinum 2 is Pt2+. Okay, the next we have is here with valency 3, trivalent cations are your aluminium with 3+, chromium 3+, boron 3+, ferric or iron 3 is Fe3+, and gold or auric 3 we have Au3+. Note here we had silver here in divalent elements with Ag2+, but we did not have gold. We don't have gold here because gold shows valency 1 and 3 only. Okay, so again in the trivalent cations we have gold here. Okay, so next we move on to our valency 4, in which you have your lead or plumbic Pb4+. Note that we had lead in valency 2. Lead 3 is not present, lead 2 and 4 are present. Tin 4 or stannic Sn4+, platinum or platinic Pt4+, and manganese or manganic also Mn4+. All these 4 show +2 and +4 valency. Okay, not 3. The next we move on to the negative ions or the radicals, in which we have, first we start off with valency 1, monovalent elements or radicals. We have chloride Cl1-, anions. These are anions are the species with charge negative. We know that, and cations are the one with charge positive. We had already discussed about the cations. Now we will be discussing about the anions, in which the first comes is chloride 1-, bromide, iodide, fluoride, all with negative. Then we have a radical aluminate with 1 negative charge, and permanganate MnO4-, hydrogen bisulfate or simply we can call it bisulfate, that is HSO4 1 negative. Then we have here hydroxide OH negative, nitrate NO3 negative, nitrite NO2 negative. Hypochlorite is important, hypochlorite is ClO negative. Hydrogen bicarbonate or simply bicarbonate is HCO3 1 negative, and hydrogen bisulfite or bisulfite simple, it's HSO3 1 negative. Next we have the ones with valency 2, divalent elements or radicals. We have here sulfite, which comes here is with SO3 2 dinegative, or sulfate SO4 dinegative, sulfide just S dinegative, oxide is O 2 negative, and peroxide is O2 2 negative. Don't make a confusion between oxide and peroxide. Oxide is, note here, it's O2 negative, the valency is 2 negative, and it's simply 1 oxygen. And peroxide is with 2 oxygen, O2 dinegative. Carbonate is CO3 2 negative. Then we have here is chromate, CrO4 2 negative. Dichromate, we have Cr2O7 dinegative. Then silicate, SiO3 dinegative. Then we have zincate with ZnO2 dinegative, plumbite PbO2 dinegative, and plumbate is PbO3 dinegative. Keep mark in these two, plumbite and plumbate. Then manganate comes up with MnO4 dinegative, and thiosulfate is S2O3 dinegative. In the valency 2, with valency 2 we have maximum with radicals only. Next we come up with valency 3 of the anions or the trivalent elements or radicals is nitride, is with N trinegative, phosphite PO3 trinegative, phosphate PO4 trinegative, and phosphide is P3 negative. Valency 4 tetravalent elements is only one we have with carbide, that is C4 negative. We know that the valency of carbon is 4, so it is 4 negative of carbon. Coming up to the rules which we need to follow in naming some of the chemical compounds are, when metal and non-metal are to be named in a compound, the metal is written first, then the non-metal, with a given suffix "ide." The word "ide" is used. We will be explaining with an example. Think the metal used is sodium. Sodium belongs to group 1A, we know, of period 3, and chlorine is group 17, again of period 3. So the valence electron in sodium will be 1 electron, and in chlorine we'll have 7 electrons in the valence shell. So 1 electron will be lost from sodium and it will be given to chlorine. So it will be a 1 electron transfer process, and the compound is NaCl and it is named as sodium chloride. I told you it's ide. We have to write it in the end. Ide is used as the suffix. Second point is, in case of naming two non-metals, think we have a compound in which two non-metals are used. No metals are there. So what we have to do is, the non-metals are written side by side and given a prefix mono, di, tri, etc., denoting the number of the atoms of a particular element. That is, here we have nitrogen monoxide. Here nitrogen, only one atom of nitrogen, and mono means we know one. Monoxide, oxygen is 1, so it's monoxide. Then we have N2O3, that is dinitrogen, because 2 atoms of nitrogen are there, and trioxide because tri denotes 3 atoms of oxygen we have. Then phosphorus trichloride, we have PCl3, phosphorus with 1 atom of phosphorus, here P, and trichloride, there are 3 atoms of chlorine. The third case is, in case of 2 elements we have and oxygen. The 2 elements are written side by side and oxygen is written after it. Oxygen is named with the suffix ate and ite. When do we use ate? One with more oxygen, and ite we have the one with less oxygen. Example we can give is of this potassium chlorate. We have one element is potassium, the second one is chlorine. Then the oxygen, KClO3. We'll use 8 here because here it is KClO2. So when we have the lesser number of oxygen, it is named as ite, and when we have more number of oxygen atom, we have it 8. So it is potassium chlorate, and here it is potassium chloride. We can give example of another compound is here potassium hypochlorite, which has the formula KClO. We know the valency of potassium is 1 plus, and the valency of ClO, this is a radical with 1 negative. I gave you the valency chart. We had hypochlorite as ClO 1 negative, so the formula is KClO. Now next we have is again your potassium perchlorate. Okay, the formula here will be KClO4. Okay, we had before here we had potassium chlorate as KClO3, potassium chloride as KClO2. Then we can write KClO as potassium hypochlorite and potassium perchlorate as KClO4. Here the radical used is perchlorate as ClO4, 1 negative. Okay. Now we have some of the steps of writing the chemical formula. Step 1 is write the symbol of the positive atom or the cation on the left side and the symbol of the negative atom or the radical on the right side. Example we have is of your calcium sulfite, that is calcium is the metal, it's written on the left side, Ca, and sulfite with the formula SO3. Step 2 is write the valency of each atom or radical on its top right side. That here we took an example of calcium sulfite, so we write it as calcium, the valency is 2 plus and sulfite is dinegative, so 2 minus. Or we take another example of potassium bisulfite, potassium with valency 1 positive and bisulfite radical with 1 negative. The third step is interchange the valency number of each atom or radical and shift it to the lower right side of the atom and or radical. For example, we have here chromium sulfate. The valency of chromium we know is 3 positive and sulfate, the radical, has the valency 2 negative. We interchange it by the crisscross method. Chromium gets the valency of dinegative and sulfate gets 3 positive. So the formula is Cr2SO4 3 whole 3. Here we have another example of calcium silicate. The valency of calcium we know is 2 plus and silicate radical has the valency of dinegative. So as we see, both have the same valencies, only the signs are different. Here it's 2 positive and here 2 negative, so we cancel it out. And it turns out to be 1 here and 1 here. After interchanging it, it's CaSiO3. Now some things which are to be noted is, in case the valency number of both the atoms or radicals is the same. Here in this case, like calcium we had 2 plus and silicate 2 negative. What we do is, we divide by the highest common factor, that is the HCF. What is the HCF of 2 and 2? Both comes out to be 2. We divide both sides by 2. 2 plus by 2, 2 minus by 2 cancels out to be 1 and 1, as I explained before. Next point is, if valency number of the radical in the compound is 2 or above 2, then enclose the radical in a bracket with the numbers on the right of the bracket at the bottom, as we did in this. The valency number of this sulfate came out to be here greater than 2, that is 3. Here it's 2, no doubt, but after interchanging, here we got the valency of chromium, so we enclose the entire radical in the bracket and we give here 3. Okay, but we cannot just write Cr2SO4 and then 3 here. Then this 3 will just belong to this oxygen, but this 3 should belong to the entire radical. So we enclose the entire radical SO4 in bracket, then we write 3. Now some examples we have is of your ammonium chloride. The valency is of ammonium radical is +1 and chlorine is 1 negative. So after interchanging we have NH4Cl. Second we have of your magnesium nitride. Valency of magnesium we know is 2 plus and nitride with 3 negative. After interchanging it comes out to be Mg3 and N2. Next we have is zinc nitrate. Zinc with valency 2 plus and nitrate with the radical valency of 1 negative. So after interchanging zinc and NO3 whole 2. Aluminium hydroxide is aluminium 3 plus, we know the valency of aluminium is 3 plus, and OH 1 negative. So after interchanging it comes out to be AlOH whole 3. So that's all for today's video. I hope you people understood it. Thanks for watching. Please like, subscribe and share my channel. Thank you.